Good morning, Web3 community, and welcome to the October Infura Community Call. We got an action-packed session for you, so let's go ahead and get started. I'm Chris Anatalio, and I'm your host. Let me go ahead and share my screen. Oops. Here we go. So we got an action-packed agenda today. We got lots of guests from all around the Web3 ecosystem. Our first guest requires no introduction, e.g., our fearless leader here at Infura will be talking about a super secret or not so secret project we have going on at Infura. We have Gabriel from Ava Labs talking about Avalanche. We have Emily Lynn, our developer evangelist from Truffle, talking about her fantastic YouTube series, Web3 Unleashed. And finally, we have Tom Hay talking about our post-merge environment. I will always remember where I was when the merge happened. I was on my couch. It was kind of like the moon landing of our time. That might be a bit melodramatic, but that's how I feel about it. So let's go ahead and hand off the mic to EG, and he's going to be talking about Defura, our decentralized initiative here at Infura. So I'm going to go ahead and stop sharing, and then you can go ahead and take over, EG.
Cool. Thanks, Chris. Hey, everybody.
Definitely.
Great to be able to chat with you again today about what we're working on with our decentralization initiatives. You might have caught our announcement at ETH Berlin last month. That was really exciting for us because we were able to talk publicly about the work we've been doing for years now for the first time. It's been a challenge for us being a traditional SaaS service in the Web3 space. There's a lot of challenges that we have to solve, a lot of criticism that we take for being a traditionally centralized SaaS service. And in the meanwhile, we have problems that we have to solve in terms of scalability and reliability of the service. And all the while thinking about how best to decentralize our service and make our service more crypto native and Web3 native. And so at ETH Berlin at the beginning of September, we had announced that we're starting this decentralized network initiative, which is what we started to share the details of. I'm going to be at DevCon next week with a couple of our teammates talking about more of the details of what this network is and the current work on it so far. But in case you missed the Berlin announcement, I was going to use a little bit of the time that we have today to go over some of the details of that and then have a more active Q&A about it, since the Berlin keynote really didn't leave or it wasn't in the format that allowed us to engage with the audience about it. So looking forward to doing that with you today. Chris, anything else before I get started with that?
Yeah, go ahead and dive in.
Cool. All right. So I'm going to pull up one sec. All right. Uh-oh. Permission issues, sorry. All right, there we go. Oh, Chris, it's going to have me, sorry about this. I think an update's making me close my Chrome screen and reopen it. So I'm going to have to do that in a second so that I can share my screen.
Okay, sounds good.
All right, give me 1 sec.
No problem. Well, while we're waiting, I guess I'm just gonna randomly talk about the merge and how amazing it was. So it's kind of amazing that one of the most difficult and like efforts that is a culmination of 7 years of effort for the Ethereum Foundation went off without a hitch. we're in the proof of stake era. And yeah, so, sorry, AG, I was just rambling about the merge while you were restarting.
All good. Okay, are you able to see my screen now?
Yes, we can.
Cool. All right. So what we called this was the start of our path to decentralization. And what I'll walk you through really quick is what we were talking about there about the why. So the why was we wanted to start sharing some of the solutions that we've come up with for how to scale access to the connections to Web3 networks. So when I say connections to Web3 networks, that doesn't mean that doesn't mean much to a lot of people. We used to call ourselves RPC API access or blockchain API access, your connection to Web3. However it is that people would call us node providers or blockchain infrastructure. There's so many different ways that people refer to Infura and Infura-like services. But what we really do is we connect people to Web3. Web3 is a peer-to-peer network, and to be able to consume data and send transactions to it, you have to be connected to it. And so how do we decentralize that access? Because traditionally you did it by running your own node. And that's something that Infura proved was not explicit or not necessary, because there are services that can pop up to help less technical users or people that want to abstract that complexity to serve users that want to connect to the blockchain without having to run their own infrastructure. But that leads to this like forcing centralization and proprietary software. And we were saying that if we wanted this space to continue to grow and to truly be decentralized in the future, we needed to start sharing more of what we've developed internally that up until now has been closed source proprietary implementations, and make it something that can help further the adoption of the rest of the ecosystem. Because by us open sourcing our tooling, just like the EVM by being open source showed that there are other implementations of EVM chains and innovations that can be spread across different solutions, and the solutions that provides to developers and to users, it's overall a net positive for the space. So just like how Geth is always joked about as being, the basis for a lot of these layer 2s and other layer EVM based layer 1s, you can look at some of the things that we're going to be sharing within Infura as what helps the scalability across many of the other chains as well. This was something talking about our early work from 2017. In 2017, people were constantly trying to come up with different ideas on utility tokens. How could we focus on specific utility tokenizing incentives for that utility and launching a network for it? And this was the whole ICO craze of 2017 and early 2018. We don't hear as much about these types of utility tokens and solutions anymore, because people are more focused on DeFi and liquidity farming, and a lot of the things more focused on decentralized finance and now NFTs. But some of the great work that was done with utility tokens was things that we were following, whether it's on like core infrastructure or other layers of service that can be built on top of that. These are some screenshots of some of the early ideas that we were trying to play around with, of how did you incentivize people to run your own node. So we had this mock-up of, well, someone can go to this Infura hub and then launch their own node and have this interface to determine if it's a full archive node or what client type they want to add, and we'll give them a way to interact and restart it and upgrade it so that it's sort of like a in the middle. Like that's the thing that you'll see consistently with all of the solutions that we've created within Infura, is that we always try to take not just like a purely decentralized approach, because oftentimes that ended up being still too much friction to solve the main goal, for us, which was getting more users and adoption into Web3. So we would take this middle of the path route, which was we would still host the node, but we would give the user more direct control over it, allow them to upgrade, restart it, etc. And then there was this button down here that we said would activate a mesh mode, which would then have it join a network where they could earn rewards for serving traffic for the network. That was a pretty basic idea. And a lot of the but even as basic as it was, the primitives that you needed to make something like this happen didn't really exist yet. The ideas were there, the idea of micropayments, how to track usage of the node, how to get paid out in rewards, what those rewards would be. Like, people were talking about and iterating on those things, but we didn't have the ability to put all of our initiatives or all of our effort into that initiative, because at the time we were a team of like 5 people, and those 5 people were 100% focused on just keeping the Infura API online and available, so that all of the new MetaMask users and early users of Web3 dApps were able to access Ethereum initially, and now other networks. But at the time, it was just Ethereum that we were serving, and that was more than keeping us consumed. With every ICO that was launching on Ethereum, where people were using MetaMask to buy into these ICOs, we were in a position of having to scale that, and so we weren't able to put more of our time into what we really would have liked to, which was how to do this in a decentralized way. And so we started to iterate on that as time allowed, and thought about how we would move from being just a single point in the network to being a federated network of node providers, which is kind of what you have today. You have a federated, not network, but community of node providers, where there are other alternatives to Infura that now exist that can try to serve the same user base with similar levels of traffic, with similar levels of quality of service. And when you think about what roles there are in that network, you start to think about things in terms of a traditional decentralized network design. So who are the roles? You have the user that wants to interact with an Ethereum-like network or a Web3 network. You have what we're calling an ingress node, which is if you're in like the DevOps tooling space, you'll recognize that we use Kubernetes a lot and use the term ingress as the generalized way of saying how traffic enters the network. So you have this other entity that's responsible for selling resources to the users and routing that traffic to the network. And then, of course, you have your node provider that's providing like the core data that typically comes from your blockchain node and serves the traffic in return for a reward. And then the last thing that you would have is a status watcher, where if you're familiar with layer 2s and the concept of watchtowers, it's a very similar concept to that. Something that's helping keep the network honest, something that is looking at the availability, reliability, performance, service capabilities of node providers on the network, and reporting that out to the general network so that users and other operators are aware. So this was our announcement. This was our announcement of where we were at now after the years of kind of iterating on this, was launching our decentralized infrastructure network. This was turned into a POAP that we released at ETH Berlin. There might still be some available, and we might reserve those to give out to people at a future event for our decentralized infrastructure network. But this was really exciting for us to be able to start sharing these details. And this is what it's currently looking like. One of the things that I said in my talk in Berlin is like, this is not finalized. That's why you haven't seen a white paper from us in the traditional white paper sense that people usually see in this space as, okay, now this is ready. We said that we were going to start sharing more of these details incrementally as we're continuing the R&D on this initiative. I've been focused on this effort. More and more of my time over the last year and a half has been focused on this. And now we're pulling in other people from the team to continue working on this and really starting to ramp it up because we're getting closer to where we feel like it needs to be. So in this decentralized architecture, you have the network operator. So down here, you'll see Infura listed here as a network operator. What we'd like to see is that this now becomes a network in which other operators can join and offer Infura-like or similar services. So whether it's known entities or anonymous entities, there will be a way for people to join this network. And then once you join this network, you're registering your capabilities with an on-chain node registry. So I could say, I am going to be an operator on this network serving these 5 chains with these types of capabilities, where capabilities can mean anything from I support Flashbot's private transactions, or I support archive data queries, or I support the trace API functionality, or even a proprietary API that only my operator is going to solve. It's a pretty open-ended mapping of capabilities that can be used to say, this is what I'm offering in case you're looking for these services, you can find me. And this on-chain node registry acts as a service registry, which can then be used by any user to either selectively choose the operator that they want to interact with, or randomly target an operator on the network. The routing decisions are left to the end user, and that's the thing that's important for this to be decentralized. Because imagine if there's Infura operating here in a group of a couple hundred operators. Existing Infura users might just continue to prefer to use Infura, and that'll always just give us an advantage in this network, where we're going to always have a significant amount of the traffic, and we're basically gaming the system in that by leveraging our existing market share and dominance. But for a decentralized network to actually succeed, we need to level the playing field and actually compete equally with other operators on this network. And so a user application that's pulling data from this on-chain node registry to make its routing decisions can decide on what the criteria is that their application uses for routing their traffic. It can be geographically based. Right now, Infura doesn't have points of presence all throughout the world. Maybe they're in a part of the world where latency might be lower, going with another operator, and they can say latency from this region is going to be how I want my traffic routed. And that forces all operators or Infura to adjust our quality of service accordingly. If we say, hey, we're losing out on traffic coming from this region, then that forces us to optimize our service in that region, whether it's deploying new infrastructure in that region or sizing up our capabilities in that region, right? Now there's signals in both directions rather than just one direction, where we can we're forced to adjust to meet network demand. And then maybe this user is saying they're going to route only based on where you're located, like they only want to deal with operators that are based in the US, or they only want to deal with operators based in Europe for whatever reason that they might have to serve their business needs. And maybe it's just purely based on performance. We want to decide purely based on performance where our traffic gets routed. And that's where these network watchers come in. So these network watchers are those watchtower-like entities that I was mentioning that can run these scripts or checks. So if you're familiar with Pingdom and Datadog and all of these other types of monitoring services, in a traditional centralized service, whenever you have traffic getting routed from an edge to a backend, you typically have a health check that's going to be running some sort of script that says, this backend is healthy, and so I can route traffic to it. This is a decentralized version of that. And the scripts and things that these network watchers would run will initially be things that we're going to develop to get this network set up. And at some point, this can be really anything that the participants on the network want the network watchers to run. So these network watchers can run these scripts to check, do these services offer capabilities that support this network? So each network is going to be different. Each network is going to have different types of checks, and it can be completely configurable. And it's these watchers are reporting into the registry. And then with that information, whether it was on which services are actually available or the performance checks that were customized to run on those watchers, now these users have the information to consume the data from the network based on however their traffic gets routed. And then lastly, that ingress operator that I was talking about is really the magic that will allow this network to really function. Is how does this RPC consumer or user actually interact with this network and pay for services and consume these services? Like, this is the thing that will be able to accept fiat payments or token payments or whatever this ingress operator decides to accept for payment, and paying the operators on the network accordingly, and routing the traffic across the network. So there's two different endpoints here. Sorry, ingress points to the network. A user can directly be sending their traffic to the network, or they can be going through this ingress operator. And again, this is where we decided that we wanted to have that minimal amount of friction still available, where if you're an existing Infura user that has your credit card subscription with Infura, that gets your monthly invoice and all of that stuff, like, to have that type of traditional SaaS experience, you need to have this type of ingress operator. But that doesn't mean you don't get to participate in a decentralized network, and your traffic would only still be served by just the Infura operator. You can have this this traditional SaaS experience with us and opt into having your traffic routed across a decentralized network. And that's something that we would do because it's overall going to be the user's choice of how their traffic gets routed. It's in the end a more resilient experience than any centralized SaaS serving can provide, because no matter how great our centralized offering is, there's just a level of decentralized resiliency that's introduced by having multiple parties serving that traffic. And that's something that we're really excited to try to pioneer, is how people can interact with SaaS services in a traditional way and get those benefits of a decentralized infrastructure network. You might have tried some of the other decentralized infrastructure networks that are out there. There's pros and cons. There's a lot of different trade-offs depending on how people approach their solution. So what we want to show people is like how we're crafting our solution, what the trade-offs are that we're making, and people can make an informed decision based on how they want their infrastructure served. Chris, how am I doing on time?
You're doing pretty good. You have we have some padding, so just go ahead. Don't
Cool.
worry about
All right.
time.
Well, this is supposed to be Q&A. I don't want to just keep talking. So happy to open up for questions now if there are any.
Yeah, generally we save questions for
Okay.
the end, but
All right. So this is just kind of doing a more low-level walkthrough then of how that smart contract interaction, that on-chain node registry works. So after we deploy that smart contract onto a chain that we can use for the coordination of this network, it registers the federated users and then coordinates the resource declaration and handles payment and rewards. What that means is when each of these different node providers joins the network, they're registering themselves with this smart contract. And then through that smart contract, the users are going to be able to see the different services that the node providers are offering, maybe different rates for payment for these services, and the reward that the providers would be able to get for serving traffic on these respective networks. What that means is that you can foresee different networks offering different rewards based on demand. Like maybe there's a new layer 2 that's being heavily utilized, or a new layer 1 that's been added, and there's a lot of demand, like latent demand, for serving traffic on that network. And so the rewards that are being paid out for serving that traffic might be higher than a established network that's already been on this decentralized infrastructure network for a while, like Ethereum, or one of our existing networks like Avalanche. Might be one that's already served on this network, and our capacity and demand are already in equilibrium with each other. If there's a new network that was added and demand is significantly higher than capacity, then this would be where you would start to see the payment being incentivizing more participants to join the network. Let's see. So ingress nodes would be in a position of having to purchase these resources to serve the end users. And this was that blending or middle ground that I was talking about, where if you're not a end user directly dealing with the node provider, you're going through an ingress. And this ingress is then the one that's responsible for purchasing and reserving capacity for you on this network. And then you're going through this middle person on the network to get your services. And that means that you don't need to transact in whatever token or payment type that the network is using. You can use a fiat currency even to continue to pay for services. So for that that user, this is the traditional cycle that you go through, just paying the ingress node for the services and then getting your API access back. To the end user, it still looks like and feels like Web 2. And then that ingress node is the one that's responsible for routing the requests accordingly based on the user's choices in their configuration. Then the status watchers, by being part of this network, besides allowing for the routing decisions to happen, also give us a way of building these decentralized status pages where you're not relying on a single point to report the status of your network. Everybody is able to build up this page from like a public stream of information. And so there could be status watchers and communities built up specifically focused on segments of the node provider network. So one that's serving like the status for a particular layer 1 or layer 2 or multiple layer 2s or whatever community is being served by this. So you can imagine like an NFT marketplace that might build up its own status page to show the status of its infrastructure providers that it uses for its underlying assets. And then this is just that overview of the first diagram, again, in a slightly more technical form, showing the flow of information and the different interactions between the parties on the network. But that was it for the overall presentation. I can switch back to this other slide if it's something that we want to keep on during the Q&A so that people have that overview in the background. But that was it. So
Cool.
Let me think. Any closing thoughts? Like I said,
E.g., there was one question in the chat, like, how will it be decentralized? Which I think you just explained, the ingress. And then what are the advantages? So I think people are kind of struggling with trying to understand the advantages to end users. If maybe you could talk about that.
The benefits to the end users. So what we were trying to incentivize here is how do we how do we make sure that every segment of the Web3 ecosystem is able to be served by Infura-like quality of service? You can think of the different chains that Infura supports, where before it was just Ethereum. And then we started to grow with the different layer 2s, Polygon, Arbitrum Optimism, Avalanche, Starknet. Like, we now support over 10, I believe it's close to a dozen different networks now. And that's still nowhere near enough to serve all of the users that need to interact with these various chains. Like, just a few that we don't currently support: Solana, Moonbeam, Gnosis Chain, Binance. There are many users and entities that come to us asking for us to support all of these networks, and we're only able to add them at the speed that a single entity can add them. But if we open source and share a lot of what we've created to be able to serve this traffic, and we can help create the incentives for people to serve this traffic, that demand should be eaten up pretty quickly. Like, think about how quickly liquidity pools are funded when there's new avenues to accruing value for people. Like, people find it, and they latch onto those opportunities as soon as they exist. One of the things that I see is, like, there's a lot of people that are skeptical about, like, what's been the value of this thing or that thing in Web3. One thing that's pretty clear to me is that Web3 has shown that people are willing to run infrastructure when there's value in it, and that time of, like, recognizing the value opportunity and actually serving the traffic is getting, like, shorter and shorter. And so we can incentivize people to serve this so that you don't end up in a point where assets are sitting on a chain that people don't really have scalable access to. I think everybody's had the experience of trying to interact with a smaller network, like a relatively new network, and there's no like consistently reliable RPC provider serving that network, or you actually have to run your own infrastructure to access those networks. And if there's an infrastructure network like the one that I'm describing here, the incentives to serve that network are going to be created by this demand from the user side. And then the infrastructure providers are going to already have tooling that can be quickly modified if it isn't already compatible to serve that demand. And so that's one of the benefits. The other thing is that we feel like we're at a point where the ecosystem has relied on this fairly heavily in the past, especially in like 2017, 2018, 2019. It's been less and less over time, which is a good thing, because you don't want 90% of Ethereum transactions or Web3 transactions flowing through a single centralized entity. We've seen that is, it's a concern because it is a single point of failure, both for technical reasons and non-technical reasons. It's not something that we want to end up with is 5 years down the road, we're at a point where all of Web3 transactions are being sent through a handful of centralized entities. That's not something any of us got into this space to try to see in the future. But it is trending in that direction. It's trending in that direction because infrastructure for Web3 does get more difficult to maintain over time, more expensive to maintain, because there isn't a single blockchain that uses less data today than it did yesterday. Every day, blockchains are growing in size, and that's just the nature of adding transactions on chain. And that's why you have people talking about why you shouldn't be increasing the block size, and you shouldn't be spamming tens of thousands, hundreds of thousands of transactions per second onto a chain, because at some point somebody has to pay for that. Somebody has to pay for that small bit of information that's added onto the chain. So unless you're looking forward and trying to solve this problem in a decentralized way, which is which we think is this, it won't end up in a good spot 5-10 years from now.
Awesome. Cool. Thank you so much, EG.
Sure.
Yeah. I mean, running a node, a highly available node, is a non-trivial task, when you try to support tens or hundreds of millions of users, as we enter in the early majority of the adoption curve. So this is like an amazing paradigm shift, just to future-proof us, as an industry. I mean, I'm biased, but I think it's an amazing paradigm shift. So thank you, EG.
Sure. Thanks. Thanks, everybody.
Super cool. Yeah. So next up, we have Gabriel from Ava Labs. Gonna go ahead and share. Oops. Here we go. Cool. Go ahead and take it away, Gabriel.
Excellent. Thank you so much. Can everybody hear me okay?
Yep. Coming through loud and clear.
Awesome. Excellent. So thank you, everybody, for having me today. It's a great honor. I want to express gratitude to the team for the time and the opportunity. So thank you very much. As he mentioned, my name is Gabriel Cardona. I am a developer evangelist from Ava Labs, and I have a few minutes today to tell you about the Avalanche network and talk about a few of the amazing things that set it apart from other blockchain networks. So we're going to go ahead and dig on in. Can you go to the next slide? Okay, so a very basic question is simply, what is Avalanche? So Avalanche is a global financial network for the issuing and trading of all digital goods. And we enable potentially millions of validators to process thousands of transactions per second with near instant finality using a protocol which is completely green and quiescent. And we have paired this high throughput and fast finality protocol with an architecture that can really meet the needs of unique financial services and decentralized applications. And we accomplish this through this notion of subnets or subnetworks. So subnets allow anybody anywhere to spin up a tailor-made network with custom virtual machines and complex validator rule sets. And so the way to really wrap your mind around Avalanche is to think of it as a network of networks or a platform of platforms. And we envision thousands and thousands of these public and private subnets to all emerge into this global marketplace that we call the Internet of Finance. And so now I'm just going to talk about Avalanche Consensus, virtual machines, a network of network, and subnets. We're going to briefly dig into each of the topics which we believe make Avalanche a paradigm shift. Next slide, please. Okay, so if you work in the blockchain space, you probably hear the word consensus like 1,000 times a day. But what is consensus? So consensus is the process by which a series of individuals come into agreement on a decision. So that's really it. How do you get people, or in our case, machines, to agree on something? That's what consensus is. And it's a very, very rich field of computer science. It goes back at least 40 years. And there have been really 3 big paradigm shifts in the world in the study of consensus. Can you go to the next slide, please? Thank you, sir. And so, as I mentioned, this is a very rich field of study. It goes back many, many years. And the first paradigm was what we call classical consensus. This was in the 70s and the 80s. And classical consensus, you can see on this chart here on the right, it had, it's very lightweight. It's very quick. There's very fast finality. It's pretty green. It doesn't really perform that well in adversarial conditions, and it's not that sort of decentralized and robust. In 2008, 2009, when Satoshi Nakamoto released Bitcoin, the world was introduced to Nakamoto consensus, and that is the second paradigm, which you can see in the middle there. And so Nakamoto consensus is very decentralized and very scalable. It's pretty robust. It performs okay in adversarial conditions up to the famous 51% attack, but it doesn't have fast throughput. It only does a handful of transactions per second. It doesn't have fast finality. If we're talking about the layer 1 network, of course, I'm not talking about the Lightning Network or any of those technologies regarding simply the layer 1 Bitcoin network. It doesn't have quick finality. It takes around 6 blocks before you can be confident your transaction will not be reorged out from under you. That's around an hour because each block takes roughly 10 minutes. It's not very green. I think everybody knows the meme of Bitcoin burning more energy than some nation states. And it doesn't have native tokens. Yes, you can write arbitrary data using op return, and you can sort of create wallets which can parse that data and make sense of it, but it's not native to the virtual machine. It has a very cumbersome and awkward to use scripting language known as script. It's stack based, and if you came of age in the modern time of Python or TypeScript or Golang or whatever, it feels very, very awkward to use. It feels like you're using Forth or something from the 60s and 70s. So Nakamoto Consensus is great, but it left something to be desired. And in 2018, a pseudonymous group known as Team Rocket released a white paper on the IPFS, the Interplanetary File System, introducing the world to the third paradigm, which is known as Avalanche Consensus. And Avalanche Consensus is really like the perfect storm of features from classical and Nakamoto Consensus. So it's very, we have extremely high throughput, 4,500 transactions per second. We have sub-second immutable and irreversible finality. So there is no idea, there's no concept of a reorg attack on Avalanche. When your transaction settles, it's for all time, and it takes less than a second. So this is a huge paradigm shift. And this is something that it's very technical, so sometimes people don't get it, but if you understand this, you can really, really appreciate that this is a huge, huge, huge leap forward. It's very green and quiescent, as I mentioned. You can run it on a VPS droplet, you can run it on a MacBook, a PC. You used to be able to run it on Raspberry Pis and Internet of Things devices. Since then, it's not capable currently at the moment, but those are really just implementation details within our Golang client. In the future, you will be able to run it on Internet of Things devices again. And it's parameterizable, so it performs very, very well in adversarial conditions. So that is Avalanche Consensus. Can you go to the next slide, please? Next, and go to the next slide as well, please. Next, Avalanche is a network of networks. So unlike traditional blockchain networks, let's think Bitcoin or Ethereum, where you have one virtual machine, so the Bitcoin virtual machine, and then one group of validators or miners, the Bitcoin miners. Same thing with Ethereum. You have the Ethereum virtual machine and then the miners. Avalanche is actually a network of networks. So we'll talk about these abstractions next, but we provide developers with the tooling of virtual machines and subnets, which allow you to really launch your own network. Think of it as an L1, and you get all of the goodies that I just mentioned out of the box of Avalanche. So you get the fast finality, the high throughput, all of this other stuff. And you can see in this visualization here, the gray oval is the Avalanche network. Inside the circles represent all of the different subnets. And inside the circles are green squares, which represent the virtual machines or the blockchains which are running on each of these subnets. And then you can see the lines between the circles, which represent the ability to swap assets and resources and users between the different subnets. And then you can see at the top, Ethereum and Bitcoin and Cosmos, we have bridge.avax.network, which actually allows you to bridge assets between Ethereum and Avalanche and Bitcoin and Avalanche. There's already been close to $100 billion in ERC20 tokens swapped between Ethereum and Avalanche, and then Bitcoin, which has only been live for maybe like 2 months, has also been incredibly successful. So Avalanche is different than traditional blockchain networks in that we are a network of networks. We are a platform of platforms. Can you go to the next slide, please? Thank you, Shar. So next is virtual machines. So a virtual machine defines the application level logic of your blockchain. So technically speaking, a virtual machine specifies your blockchain state, a state transition function, transactions, and an API through which users can interact with your blockchain. And every blockchain that's running on Avalanche is an instance of a virtual machine. So the way to think about this is it's very similar to a class in object-oriented programming. So a class is a description of an object. It's a template from which you can instantiate as many objects as you wish. And each of these objects, though they were derived from a common template, they're all unique and they're logically separate entities with their own state. So similar to a class, a virtual machine is a blueprint or a template from which you can instantiate as many different instances of a blockchain as you wish. And each of these blockchains, though they were all derived from a common template, they're all unique and they're all logically separate entities with their own state. And as a developer, when you write a virtual machine, you don't need to concern yourself with lower level logic like networking or consensus or the data structure of your blockchain. Avalanche does all of this behind the scenes for you, so you can focus on the special thing that makes your virtual machine unique. Can we go to the next slide? Actually, the next one as well. So we'll talk about subnets. So subnets are dynamic sets of validators working together to achieve consensus on the state of a set of blockchains. And every single blockchain is validated by exactly one subnet, and a subnet can validate many blockchains. And subnets, they manage their own membership, so they can require that their constituent validators have certain properties, which is very useful. They're very, very good for regulatory compliance. So you can say, for example, all of the validators in my subnet need to be located in this certain country or legal jurisdiction. All of the validators in my subnet need to meet KYC AML requirements. All the validators need to hold a certain license. There's also support for private blockchains. There's separation of concerns, and then there's application-specific requirements. So if you have an app that requires large amounts of RAM or CPU power, you can actually require that validators meet certain hardware requirements so that the application doesn't suffer from low performance. That was the 10 minutes. So can you go to the next slide? I think let's go to the last slide. One more, and then one more, please.
One more.
Yeah, thank you. So yeah, just to wrap it up. So what is Avalanche? Avalanche is a global financial network for the issuing and trading of all digital goods. And we enable potentially millions of validators to process thousands of transactions per second with near instant finality. And we do this using a protocol which is completely green and quiescent. And we have paired this high throughput, fast finality protocol with an architecture that really meets the needs of unique financial services and decentralized applications. And we accomplish this through this notion of subnets. So subnets allow anyone anywhere to spin up a tailor-made network with complex virtual machines and validator rule sets. And so again, the way to think about Avalanche is we are a network of networks, a platform of platforms, and we envision thousands and thousands of these public and private subnets to all emerge into this global marketplace that we call the Internet of Finance. My name is Gabriel Cardona. I'm a developer evangelist at Avalanche Labs. CG Cardona is my Twitter and my Telegram handle. Feel free to reach out to me. I'm happy to help on-ramp developers and teams into our ecosystem and to answer any questions. Thank you again for having me.
Wow. Cool. Thank you, Gabriel. Yeah, I always knew. Yeah, definitely. I always knew Avalanche was like a highly scalable solution, but I didn't realize it was such a holistic solution, almost functioning like a layer 0, where you could create like an application specific blockchain tailor-made for like this. Yeah. Wow. Okay. Super cool. Thank you. Very insightful.
Thank you.
Awesome. All right. So we've been saying when merge for like 7 years, and now we're saying remember merge. So it's kind of crazy. So let's invite Tom to the mic, and he's going to talk about what we're doing now in the post-merge era. Oh, let me invite him on stage. All right. So we got Tom coming on. Here we go.
Hey, everybody. Thanks for inviting me up, Chris. Okay, so hi, I'm Tom Hay. I am a product manager on Infura. If you've been following along with the merge, myself and some other colleagues from Infura and also from the greater Consensus family have been doing did a series of workshops about the merge. Well, guess what? The merge happened. We did it. We're on Ethereum. So let's just talk about what's next for our Ethereum API. So first off, testnets. Gurley and Sepolia are the supported Ethereum testnets. As of this point, Rinkeby, Ropsten, Kovan, Arbitrum, Rinkeby, Optimism, Kovan, they're all deprecated. Everything is Gurley and Sepolia. And you've probably seen emails, announcements in the app, blogs, tweets. If you are not receiving the emails, please reach out to me. I would love to figure out if there's any issues that you have in hearing the deprecation announcements. Definitely want to resolve that. Ethereum API. Our Ethereum API is currently the execution layer API of Ethereum. We've had an open beta of a separate beacon chain API, and we are deprecating that. That is going to give us a chance to consolidate. Like right now, you see those are on two different, you have to create two different projects, API keys to get access to that. Now that we're past the merge, this is going to give us that opportunity to sort of optimize that infrastructure. I see a question in there from Remy, like, why are you planning to remove it? Really, it's to optimize our overall Ethereum offering. So this is going to allow us to make some changes. The Beacon Chain API has been in beta for a while now. And we want to make sure that we're having the best holistic Ethereum offering long-term. So being able to do this deprecation in the short term is going to long-term allow us to continue to make our Ethereum API the most performant and holistic, and make sure that user experience is continuously great, and especially under the paradigm of proof of stake Ethereum. So then we've heard these talks about the surge, the verge, the purge, and the splurge. We are continuing to support the Ethereum roadmap and collaborate with the Ethereum Foundation community. You can always reach out to me. You can find me in Discord. I shared a Discord link in there as well. Please reach out. We're always willing to have a conversation on how we can best meet your needs with regards to Ethereum and the Ethereum API. So exciting times. Excited to talk more. I hope to see all of you in Discord, and I will turn it over to the wonderful and prodigious Emily Lynn, who, if you are not watching Web3 Unleashed, you are missing out.
Super cool. So yeah, go ahead and take over sharing, Emily.
Okay, so I'm Emily. I'm the Truffle developer advocate. I think they've probably talked about this series before on the Infura call, but just wanted to come plug it as we've kind of matured as a product, or not as a product, as a stream. So for those of you who don't know, Web3 Unleashed is basically a weekly live stream about all things Web3. It's hosted by Truffle, but it's not necessarily by Truffle. So if you can see, I'm going to start sharing my screen. To give you an idea of like what kind of content has been produced so far. Cool. So if everyone can see that, basically we have all these YouTube videos. So we started from like, I guess the very beginning of smart contracts, specifically the rentable NFT smart contract, which is ERC 4907, is the most recent one. So that's kind of blossomed from interviewing the researcher who created the base contract, implementing it on our own together, I guess adding it into an NFT rental marketplace, kind of the whole smart contract flow. And then the next week, then the reason I'm on the Infura call is 2 weeks from now, we'll be building the front end for the NFT marketplace, which does incorporate the Infura NFT API specifically to retrieve all your NFTs to see if they can be rented. So that's super exciting. Chris will be joining. If you're a fan of him, you'll be a fan of us together. But yeah, last week it was yesterday. Yesterday we had a stream with MetaMask to talk about the MetaMask API. So if you kind of want to get a glimpse into also the cross-pollination or consensus family activities, it's also a really good way to get involved. But otherwise, if you want to see like what's coming up, it's all public on our GitHub repo under projects. Kind of what's been created so far. I'm really excited about L2 bridging on Optimism. We're bringing a dev from there, talking about push protocol, Gelato, smart contract automation. There's a lot of content, and it is always growing, so it's always open to suggestions. And I hope to see you guys there. It's live, but things are recorded, and each episode also comes with a guide. So if you don't like watching things, that's fine. It's all there for you to implement on your own. So yeah, I mean, that's all I have to say.
Cool.
Yeah, I don't know. Join me and Chris in a while, in a bit. The hottest collab of the year.
The week.
The
hour.
week. Yeah, not necessarily. I mean, like, we were with MetaMask yesterday, so I feel like I can't play favorites, you know?
Oh, that's fair. Yeah.
Yeah.
Cool. Thank you, Emily. You've been releasing content at a furious pace, and like it's always super fun and super educational. So thank you.
That's good. Yeah. So
Cool. Yep. Alrighty. So that's all our guests. Just as a reminder, we will be setting out these slides in case you need these links. So as EG was talking about before, if you're interested in being a infrastructure provider, we have an early access program you could sign up for. We'll be sending out that link. We'll also be sending out a link to EG's letter on the vision for how we decentralize node access at scale to handle hundreds of millions of users when they onboard to blockchain and crypto in general. And then we have some press about our fancy plan to decentralize. And don't forget to follow Gabriel and Emily on Twitter to keep up on their news in the tweetosphere. And we have all of Emily's Web3 Unleashed videos on YouTube. So be sure to check them out. There's a bunch of them. They're super cool. Be sure to sign up for my office hours and join us on Discord for technical questions or just funny commentary. And be sure to follow Infura on all of our social media platforms, Twitter, YouTube. And yeah, I guess that's about it. So thank you so much for joining us. Thank you to our guests. It's been a super cool community call. And yeah, everyone out there, keep on building or biddling, as they say. So thank you, everyone, and have a great day. Cool. Thank you, EG, Tom, Emily, Gabriel. See ya.
Thanks, Chris.
Yep, definitely.